This month, I set my goal to build a flight computer for a simple rocket project. I've gotten my hands on some basic components, like an altitude sensor and a microcontroller. This will be my first rocket build, which means I have zero experience in this field. And zero experience usually means lots of stupid mistakes, like the ones I made just a day ago while assembling the main flight computer. This is my DIY flight computer, and I'm proud of it because it turned out better than I expected. Even though, to be honest, it is a piece of junk. Why? I'll explain that later in the video. It all started when I placed orders for the components. Once the packages arrived, I recorded an unboxing video. After that, I made another video where I tested all the components. During testing, I discovered that the MOSFET module I had wasn't a logic level MOSFET, which means it wouldn't work with 3.3 volts. At the end of that video, I mentioned that I'd be ordering a new MOSFET for the flight computer. And after receiving the new parts, I assembled everything off camera and built this flight computer. All the parts are assembled on two perf boards that are joined together to create a larger surface area. The microcontroller is placed in the top left corner and the altitude sensor is positioned in the top right corner. Just above the sensor, there are two header pins for connecting the battery. The bottom half of the perf board contains the SD card module for data logging, an IRFZ44N MOSFET to ignite the Pyro charges, 1,220 ohm resistor, 110 k ohm resistor, and a screw terminal to connect the Pyro charges. As soon as I completed the build, I connected the flight computer to my laptop and tested each component. The BMP sensor worked flawlessly. The flight computer successfully logged data to the SD card, and the MOSFET functioned perfectly, ready to ignite the Pyro charges. It was a huge relief, as the flight computer is now complete. I can finally move on to building the rocket motor. It didn't work as I expected. Only the BMP sensor is functioning. The SD card module isn't responding and the MOSFET is still acting like a useless piece of stone just sitting on the perf board. That was a big mistake. I should have tested each component individually before soldering them onto the perf board. Now, I have to replace those parts all over again. I made the same dumb mistake I did the first time, buying a MOSFET and SD card module that weren't designed to operate at 3.3 volts. The second time, even after ordering new components, I didn't carefully check whether they were 3.3 volts compatible or not. I was too confident, so as soon as the items arrived, I jumped straight into building the main flight computer. It's frustrating, but I've definitely learned the importance of testing everything thoroughly before final assembly. All the work I put into building the flight computer ended up being wasted for the second time. In hindsight, the microcontroller I chose as the foundation of the project, the Raspberry Pi Pico, wasn't the right choice for a rocket flight computer. As we've learned, the Pico operates at 3.3 V logic levels. This means that any component requiring 5-volt logic needs a level shifter to convert 3.3 volt signals to 5 volts, adding unnecessary complexity. If I had instead chosen the Arduino Nano, a low-cost alternative to the Pico, I wouldn't have had to rebuild the entire flight computer. The Nano operates at 5V logic, which makes it much easier to integrate with common components without worrying about voltage compatibility or searching for logic-level compatible modules. I wish I had known about this earlier. But now, I have no other option than to continue using the Pico as the microcontroller. That means I need to find a logic-level MOSFET and a compatible SD card module once again. I could use a logic-level shifter, but that setup would cost around 450 rupees, which feels too expensive for such a small fix. That's why I've decided to buy new components like I did before. But this time, I'll be much more careful with my choices. Videos like this may seem simple, but for someone just starting out with building a flight computer, they can be incredibly helpful. Small creators like me don't just post videos to earn. We genuinely want to help others complete their projects too. Our mistakes often become valuable lessons for those who are beginning from scratch. I'll be sharing more updates, including shorts or posts on Instagram, whenever I complete my flight computer or reach a new milestone. If you made it this far, thank you so much for watching. If possible, leave a little comment to keep me motivated. I'll see you in the next video.